Welcome to Artificiality, brought to you by the founders of Sonder Studio. Artificiality is a podcast dedicated to understanding the emerging community that is humans and machines. We take the latest in the human side, decision science, psychology, and design, and put it together with advances in artificial intelligence and big data so that you can understand how to work better with machines and your fellow humans. We founded Sonder Studio to help people be more human in the age of AI. We're on this learning journey too, so we strive to find the frontiers, to ask the best questions, and stay curious. We interview some of the top minds working at the intersection of humans and machines and make sure we have a few laughs along the way. Have you ever wondered about what it takes to design AI that doesn't do more harm than good? We speak with Josh Lovejoy, who is perhaps the most experienced out there in the field of human-centered AI design. At the time of our recording, Josh was head of design for Microsoft's Ethics and Society team. Since our recording, Josh has taken a role as a UX manager in Google's Privacy and Data Protection Office. We started our interview by asking Josh why human-centered design is so important when working with AI. Well, Josh, thanks so much for joining us. We really appreciate you taking the time, and we're excited to talk with you today.
Thank you so much for having me. I am also very excited.
Cool. Well, why don't we start off with human-centered design and what that means in terms for AI in particular, and why do you think it's so important and what's really different about working with AI in a human-centered way?
It's a big, important, and hard to make concise answer. I think most fundamentally, it's because the stuff is intended to model or be modeled after the way that human beings approach learning and experience. So if anything, we're the best representation for ourselves about how this technology should be built or could be built. It gets really messy, and I'm sure we'll talk into all of the messiness as the conversation goes on about the things that are totally not human about AI. But that'd be my starting point. On the complete other side is just the fundamental truth that a person is got to be accountable at some point in the process. Question becomes where and who, but people will be responsible. And we don't necessarily have a habit today of starting with that person or those people and asking them what they need in order to take accountability for whatever comes out the other side of the system. There's a lot more, but those would be my sort of first two top level thoughts on why it's so important.
That's a super fair point on accountability, and I want to come back to that a little bit later on. I want to pick up on one of the things you said about our model in some ways is humans and humans. And can you tell us a little bit about what you've learned about automation bias when it comes to AI and how humans form relationships with machines and how that's different than how we form relationships with each other?
Yeah, absolutely. So automation bias is a cognitive bias. It's something that we can't necessarily get over. We just kind of have to deal with it. And in this case, it's a disposition or a predisposition to over rely on automation or something that is mechanical in nature. You talk about the reasons why. It's really deep in our language. We talk about machine-like efficiency. We talk about optimization. But regardless, there's a habit of associating something robotic or programs as being objective. And for the vast majority of conventional software development, that's decently true. Like the rule set is pretty clear. But so that's the start. So automation bias is the tendency to over rely on automated systems. And so where it gets really wonky with machine learning is that like these aren't programmed rules. The model is actually inverted. You develop conventional software by having people input rules and those rules get applied to inputs and situations and data and whatnot, and they produce outcomes of some sort. If this, then. With machine learning, it's the reverse. You input outcomes, and the rules get built or inferred over exposure to those outcomes and back propagation, right? Like the confirmation or rejection, the regulation of how right or wrong the rules were relative to those outcomes. So
which necessarily comes with a probability.
That's right. It's always going to be probabilistic, because if you're showing it a bunch of outcomes, you're saying use your best judgment thing. And again, it's just the way that we humans grow to learn one another. And we learn about the world is by example and by experience. But it's so fuzzy, and it's we can talk about all those different ways that it is fuzzy and probabilistic. But because you're starting with the outputs and you're working backwards towards something that seems like good enough, like a good enough set of heuristics, it's anything but objective. And therefore, this tendency to over-rely brings with it a pretty hefty risk. We sort of say there's two guaranteed outcomes of somebody not understanding fundamentally how these systems work. Misuse, which is when somebody doesn't understand what the system can do and uses it for something that it shouldn't be used for, not appropriate to be used for. And disuse, which is when somebody doesn't understand what the system can do, and so because it doesn't meet their expectations of what they find desirable or useful, they just stop using it. And so both are negative states, but they all come from this starting point of, I thought I was just going to use this as a tool reliably. It would behave in a predictable way. And so the automation bias leads to this huge kind of crest fall and surprise.
So the trust up front, it sounds like what you're saying is that you tend to have this trust up front.
That's right.
And then it falls off when it fails to meet expectations. Why do you think that? What's different about an AI system as opposed to the just rules systems? I mean, there's good example. Think of the really famous examples of automation bias around the flight out of Rio. I think Long Island is another one. The nuclear accident.
Mm-hmm.
Well-documented cases. But with AI, we don't necessarily know how pervasive it is, and whether it acts on little things or big things or all things.
Right. So first of all, there's there's a lot of overpromise about the capabilities of these systems, which I think you're getting at. But because of that overpromising, like the market hype that goes along with AI, I think it combines the automation bias, or the predisposition to over-rely, with also this expectation that it's going to be perfect, or it needs to be perfect in order to satisfy the need.
Or it's going to think the same way as a human. So you get this combination of high trust and high expectations.
It could even so much of it gets into the details of how it is proposed. So you'll have something like a context that's safety critical, like driving or medicine, where the expectation is, because there's an automation process involved, that it has the capacity to achieve perfection. Like there's a starting point. If we just put enough data into this system, if we give it enough reps, it will achieve perfection. And that's wrong. There is no amount of data that you could ever put into a system that would ever allow it to operate with perfect accuracy. Variability of the world is too high. Variability of human experience is too high. Variability of service design, hardware design, the conditions go on. And so if you just continue down this path of assuming that with enough data or with enough reps, you can get to perfection, then you're really missing the point. You're like, I won't use this system for self-driving cars because it's going to get into an accident. We're like, yeah, of course. It will for sure get into accidents. The question is, will there be fewer accidents in ways that you can tolerate? compared to the current state. Or in medicine, if I just use this thing to predict, will it get stuff wrong? Yes, it will get stuff wrong. And so can you tolerate the risk or the wrongness? And the point that I would try to make, and this is like I think the conceit of our team, or what we're trying to do, is to say, if you're starting with perfect accuracy as your goal, then you're already starting with the wrong goal. Instead, if you go back to those scenarios and say, what would be the conditions where we could actually tolerate the level of risk for automation in a driving in a automated I could talk. What are the scenarios where you can tolerate the risk in a car context, a self-driving car? What are the scenarios where you can tolerate the risk in medical context? And usually it's better by starting with talking to people. What does a clinician need in order to actually expand their awareness? And that's when you get into like actually cool stuff. Like, oh, what scans have been similar to this in the past? How can I appreciate this based on my own past experiences, the past experiences of my colleagues, people that have similarities to this individual? That's stuff that is far more about honing and augmenting your own intuition rather than relying on perfect accuracy of the system.
So how do you think about designing for presenting inaccuracy? Right. So if I'm moving a file into the cloud, I'm at this point assuming that the cloud system is going to have enough backup that it's not going to lose it. Now, that's
right.
different from 20 years ago, and we used to put things on external hard drives, and those things failed every once in a while, right? But we've now gotten to a point of reliance on certain things, and we can look at a machine and assume that it won't fail on us. But what you're presenting, which I completely agree with, is the nature of an AI system based on its trying to make a prediction around the natural world, which is fundamentally unpredictable, and also being a probabilistic system, so therefore there is always an error rate involved. How do you present a user interface to someone that says, hi, I make errors? And have people still want to use it.
Right. Yeah. This is one of the biggest hurdles to get over. And I think it's going to take several years of work to get over it. Because if you introduce that fallibility and the promise is perfect accuracy, then it seems like a bug. So you do need to reframe the value proposition. So for instance, if you want to do something related to, say, speech recognition, and you start with the knowledge that it will get a certain amount of your words wrong when it's performing transcription, either because of physical acoustic distinctions or differences between how people produce speech, or because of language differences, slang, grammar, idiomatic stuff. Then it's how do you present that? You can sort of try your best, make an inference about what the system thinks that the person said, and then render a low confidence prediction. It can produce nothing, and just say try it again. Or I would say, more interestingly, you use that as an opportunity for calibration. So again, if I introduce this as out of the box, this will work perfectly, no setup necessary, it's just magic, then you have a much smaller repertoire of error handling. And we could talk about severity of harm being different, but I'm using speech recognition for the moment. But instead, if you put something together and say, all right, listen, everyone's different. Language is always shifting. How do you talk? And what are some of the characteristics of maybe language that are more normative in, the people that you're talking with? It invites a big privacy question, which I'll put on the side for a second. And there's an answer to that, or there's an approach for that. But by doing that, every time that there's a misunderstanding of some sort, it invites a feedback loop. And that's really cool, because that's a relationship that you get to build. If it misunderstands something, I have this little design that I play with sometimes. I call it like best guess spelling, which is like, how they talk about it to kids, right? It's like, just try your best, sound it out. We used to say hooked on phonics when we were kids, right? It's like render just the phonetic representation of the transcription. because then you can actually get a sense of the mental model. Like, how does this thing produce this transcription? Now I can teach it. It's not the human as the error corrector. It's the person guiding something that can be an extension of themselves. But again, that presupposes a relationship. Like, you want to form a relationship. I'm going to invest in teaching this thing how to work so that it can be better for me in a more longitudinal kind of way. So sometimes that's at odds, right? If the business model is, this is a service, it's just magic, it works out of the box, then what you end up doing is setting yourself up for a very narrow pathway to success. So that's one of the things we try to counsel to teams. It's like, if you want a more anti-fragile approach, you should build for feedback loops, relationships, people being able to calibrate systems, configure them in a way that makes sense to them, and then use them for stuff that they find meaningful, rather than just produce an output and force the user to be a sort of a dumb terminal who consumes either a right or a wrong response and then deal with the outcomes of those responses.
I love the idea that a speech recognition system, what would it look like, if it could express confidence? So in the middle of a paragraph, there's some way that I know that it's not quite sure it knows exactly what I said, versus the parts where it's like, yeah, I got this. Like,
yeah.
No question about it. I understand it. Because when it's not sure, if the not sure lines up with what I see as inaccuracy, I'm more likely to trust it. Right? I mean, I think that's the balance that we're talking about. Is you walk into the room and you expect the machine to be perfect, because that's our bias.
Right.
And if the machine calibrates and actually expresses lower confidence in its accuracy, we might come to trust it even more.
That's right.
In terms of when it's accurate, when it's not. And if there's some level of I guess think about it as an affordance for me to go in and help it learn, then you're right, it's created a relationship. But it's a little bit hard for me. I don't really like teaching systems that I'm paying for. That doesn't feel like, that's my job. I've gotten used to it with the the CAPTCHAs, where I've now taught every system in the world what a traffic light looks like.
That's right.
Yeah, because a robot can't.
But I don't have any choice with that one. I can't get what I want without doing it. But I do feel like I've been held over a barrel a bit.
Yeah.
But I think that, I'm fascinated by this topic because I do, my history in software goes way back to when everything was role-based and the interface was set, right? So, and some of the systems were really quite complex, lots and lots of different, buttons that you had to move and very complex operations that a user would do. And then I think about the complexity that comes in where the system may be learning something based on what I'm doing so that it might present itself differently. And how absolutely confusing that becomes.
Oh, it's terrible.
As a designer. And terrifying.
Yeah, it's terrible. Don't move the cheese.
Exactly.
Yeah.
Yeah.
I mean,
Don't reorder things.
Exactly. There's people keep, this was like that first wave of like generative UI of like, again, it starts from the presumption. I've had no shortage of conversations with scientists and engineers on this subject. They start with the assumption that it can get to perfect. And the question that they're often framing it as is how much data from where, from a who, over how much time is necessary in order to achieve that perfection. So a generative UI is the same thing. You're like, well, eventually we could get to perfect. Spotify could render the exact perfect album for me to listen to, or Photoshop could somehow magically orient itself in a way that lays out to how I want it, or a news magazine or a Netflix queue could all orient themselves perfectly to meet me where I'm at. Which I think begs a different kind of a question about it's when you want to give somebody advice, you might have the best advice in the world, but if they didn't ask you for it, then they can go to hell, right? Like that's the general, like the human experience. Like somebody can walk up to you, a stranger on the street, and give you the most perfect read of who you are and where you're on and the path. And you could be like, who are you? What did I ask for this? Did I invite this kind of this deep personal connection? And that's sometimes the way that these software systems are framed. people could just put up with a bunch of, experiments and iteration because eventually they'll get perfect. So the experiments are pretty unwieldy to sort of wander through. Like you said, the UI is going to move around on you. The functionality will change. Things will actually, it'll be undependable. So they can get to perfect, where I guess you no longer have to think anymore, and it'll just walk up to you on the street and tell you exactly what you're thinking and feeling, and the perfect album to listen to, and the perfect thing to watch, and the perfect way to write a sentence. I don't think anybody wants either of those things. And that's back to the human-centered design side of it, of like, maybe your end states are a little bit flawed.
So do you think that, or what do you think of the current approaches then in terms of the mindset around personalization as a goal in and of itself?
Yeah, it's in need of some help. I think anything where, again, personalization, I would model more after a relationship. The benefit to personalization has to be a long-term benefit, I would say. And so back to Dave, your point, like, do you want to invest in this? If personalization means better recommendations for shopping or advertising, okay, maybe, but like, why? And do I want to invest in that? Is that something I'm interested in? It might mean better recommendations for stuff to consume. But I think there are a couple things that are troubling about that from a human-centered design perspective and like kind of a behavioral psych perspective. One is that people are kind of in a constant state of becoming. So there's already a flaw in that if you presuppose the possibility of getting to perfection, it means that you're either presupposing an individual is fixed and rigid in their tastes and their attitudes, or that you can predict the future of where their tastes and attitudes will be going to.
Or even guide them to their future, right?
Right. Which is great from potentially from a capitalist perspective, that you can tell people exactly what they should care about next. But it certainly isn't a relationship. So going back to the, why do I want to invest in this? The affordances are often too simplistic, like it or don't like it, consume it or don't consume it. They all happen on a really short interval. And so that's one thing that needs to be, I think, adjusted. What's a more longitudinal way to measure the way that this relationship, this personalization engine, whatever it might have been, affected something more broadly for you? So if my goal is to become a better writer, and I can personalize some sort of predictive language generation, then it could start to recommend things for me to read, maybe as inspiration. That could be cool. But as it stands right now, if you look at the stuff that people are using these large language models for, these natural language generation models for, it's really just, it can complete your sentence for you. And that's it. So no shortage of personalization gets me out of that state where the best I can do is maybe have it complete my sentences for me. At which point, isn't that just taking away my expertise? Like the thing that I wanted to set out to be better at anyway. I wanted to be a better writer. You're finishing my sentences. I'd much rather have better inspiration, better fact checking, better research, better sources of collaboration, et cetera, et cetera. So the feedback loops are challenging, the metrics are challenging, but again, that outcome, it still starts with that outcome of like perfect accuracy, perfect predictive accuracy. Does that box people out of something that they actually want to do?
I like the idea that there's a timeline to consider in terms of the feedback loop, that sometimes, frequently, the feedback loop is immediate. When we hang up from this recording session, it'll give me a 5 stars to 1 star rating right away.
Exactly.
Right? It's that. So it's the absolutely immediate. They want to get my feedback right away, which is in some ways good, right? It's a reaction in the moment, but there is a longer term thing These recordings have to download. I have to manage them. I have to see that they're quality. That's actually where the real feedback loop comes in, right? Is a little bit later. I think that's sort of true with humans too. I can think of people that I'd love to have over for a dinner party, but they may not be someone I'm going to be friends with for a very long time.
That's right.
Is there a way as a designer to separate out those two worlds, those two different things? Is there a way for a designer to approach an AI system and is there some sort of framework to apply that says, this is something that should be judged on a short-term basis and that's the accurate thing, versus this is another system that we really want to learn about the relationship over a longer period of time?
Yeah, absolutely. I'm pausing because oftentimes it's a complex answer, and so for anybody who's trying to influence someone else in their organization, who's building a product or who's just wants to make things better for better product designer overall, there's an investment in building towards something that is predictable right up front. To your point on the 5-star review, I guess my question is 5 stars about what? And does anybody want to fill in the probably 300 different telemetry measures that's associated with? There's probably something about bandwidth, bit rate, there's something about dropouts, something about audio quality, there's something about video quality, something about subjective characteristics, as well as even something like technical errors and delays. Who knows, right? Like you can come up with no shortage of things that you might want to improve or make better. And you're giving somebody this really simplistic tool that's just like, I don't know, how does this feel? And so what I would say to that is, it seems like you're wanting to build a very longitudinal measure, where with enough exposure, you could use those 5 stars as a through line as you try experiments over experiments over experiments and see if there's just a general global kind of change. But if you're looking to build something predictable, you need to start a lot more granular. So when we think about some of these systems and what people actually want to do with them, it's often not often that core, what do you want to make predictable so that people can grow to depend on it, so that they can grow to actually trust it. My shorthand is sort of can you help people sort of see from the perspective of the AI or hear from the perspective of the AI? A computer vision example might be something like if you are trying to do some sort of analysis in a physical space, object detection, or to count if a building is at capacity, or face mask detection, or, figure out if indoor navigation using whatever combination of point clouds and depth or whatever, help people move through a space. There's a first upfront thing, which is just are you generally seeing the same thing that the AI is seeing? And usually that's missing. It's you get the system and you point your phone at it or you point a camera at it, and it starts to give you a prediction. So right there, we have one of our first kind of weird AI things, which is if you train a machine learning model to guess if something is or isn't, a door, and then you point your camera at a car, it will give you a percentage confidence about how door-like that car is. You could point it at the floor and it'll give you a percentage confidence about how door-like that floor is. And part of that is because what you're doing is you as a user, has just a bunch of stuff's been skipped over, and you haven't been able to just sort of calibrate and say, are we generally talking about the same thing? So examples might be something like, maybe you could hold it up and actually have a few more granular details presented to you, like a floor grid that projects like a perspective. Like, are we looking at a floor together? If I'm doing something like warehouse management or looking at, capacity planning in a space using computer vision, do we both know where the floor is? Can we be on the same page about that? And if you are, then you have at least something that you can start to build predictable. All right, well, at least we have that we can take for granted. All right, what else do we have in common? What else can I start to build into this system so that I can have more confidence that we're looking at the same thing generally? And this is what people do whenever they have problems, right? Whenever they have disagreements or misunderstandings. I mean, some people just yell at each other. But usually, if you're trying to actually resolve something, you work backwards to find the point of commonality. And we're really pretty good at that. We don't call it debugging when human beings are trying to go through that process, but that's totally what it is. Be like, wait, do we have the same goals? And then you walk back from that into like, when that happened, did you think that was a good activity or not a good? Oh, okay, got it. We have a difference in opinion about whether or not that was, that thing was what we both thought it was. So people are good at going through that stuff ultimately because it's our only way to reason through such a complex space.
Sure. We find ways to communicate in new languages that will both point at a car, and one of us might use the word car and one might use the word vehicle, but eventually we narrow in on what car means in a different language. But an AI will look at a door and then look at the floor and say, well, but it's partial. It could be a door because it's actually made of wood.
Yeah.
Or the car might be a door because it has a handle. It's looking at things from a very foreign perspective. And
I would even say it's looking at it from a very rigid perspective. Because what you just said, so you just projected potential rationale onto like a computer vision classifier, which is great. You're like, because it has wood, right? Like they share that in common. But even that, like those are that's a semantic understanding that doesn't actually exist in the construction of that machine learning model.
Exactly. It doesn't know that.
It doesn't.
But that's the reason that I might come up with when I
exactly
right.
And we could have a back and forth, which means back and forth. Like we're committing to your earlier point about like, do I want to invest in something I paid for? We're committing to something. We're committing to like, all right, Dave and I might not be on the same page right now, but gosh, it'll be valuable if we can find each other through this activity. And that means that like, even with somebody that we do, even with, experts that, not to say we should replace experts. So sidebar on that for a second, but with an expert, somebody you're paying, you still are like, are we saying the same thing? Are we experiencing the same thing? My favorite example of this is with sign language interpreters, where I, having never used a sign language interpreter, I was doing some research on computer vision techniques of like, is there something related to lip reading or potentially American Sign Language understanding? And we had this one situation where there was a no-show, a participant missed the session. And so we just got to hang out with a couple ASL translators for a little bit. And it was a great moment of like ignorance finding because, we're just sort of like, oh, what's it like to sort of dive into such often personal experiences, going to the doctor with somebody that's like someone you just met, or having a really difficult conversation with somebody. And they're like, oh no, when we're working with a deaf or hard of hearing individual, and it's the very first or second or third or even fourth or fifth time, they totally don't trust us. Like there's a complete start. It's not a trust fall. And if they have their say, they don't invite a brand new ASL translator into a doctor's appointment. They specifically, if they can, try to find someone that they've built a relationship with. So here's an expert domain, someone that you really like need to entrust. And the reality is there will never be such a thing as perfection. And so what are they doing? The deaf or hard of hearing individual will sign. They will then watch like a hawk as the ASL translator speaks the interpretation, because they're going to change something. But what they change matters tremendously.
That's a really interesting case study to kind of think through. And it's like when we're prepared to invest in working with someone to develop this understanding of what it is, where they're coming from. There's that constant, there's a dialogue that goes back and forth that we're either trying to change their mind, or we're trying to understand them, or we're trying to convince them of something that, or our position. And that process seems difficult with AI, either because you're not as patient, you expect it to be there. It's part of, we've been trained to have certain user experience. We're impatient to get on to using the thing. We don't want to set it up. But it's the way you talk about it and the way that we form trust with machines versus with humans. Sounds like this is a really big problem just from a pure UX perspective, is how to get the balance on that right.
Absolutely. Yeah, question one should be, is this a good use case for machine learning? And I've tried a lot of different sort of pithy answers to this, but even those don't seem like they hit the mark. I'm like, is there anything where people could really benefit from having more time to do something meaningful to them, that they define meaningful, to be more present in moments that they find meaningful, again, as defined by the individual, to recall things that are meaningful or relevant to the moment. It's time, presence, memory. Those are those weird things that I think are the unique value propositions of machine learning. Generally speaking, digital systems don't forget stuff that you tell them to pay attention to. Generally speaking, they have very rapid response times, much faster than human response times, about stuff you tell them to pay attention to. And so that combination, it opens up some really interesting ways to extend our cognition and distribute our cognition, but it certainly does not replace. But it's, I don't know, from your point, what you're saying, Helen, about like, is this almost like a flawed starting point or a challenging starting point for UX? Yeah, it is, if the proposed value is immediate and somehow believed to be like globally the same for all people. Anything else will take time. And that is, in my mind, the value. I would say there's two kind of like general schools of this, and they're weirdly distant. One is where you can achieve incredibly high reliability. And that's kind of the promise, for example, of like self-driving cars, is like there'll be a crossover point in the not too distant future where if you have enough of them, then it'll be this tipping point where safety will be dramatically improved, because the biggest variability in driving is human judgment, and the response times that are needed for driving are actually probably better suited to an automated system. And the rules for driving are really well understood and well defined. Like they're not, it's not, you don't have to use intuition really as a driver that often. And it's really then what you're missing is something like the delight of driving, just the feel and the enjoyment of driving. But in terms of like straight up, like getting to places faster and more safely, you can follow the rules and achieve incredibly high reliability. And you can aspire for that spot. But then there's the other category, which is where the rules are and the conditions are variable enough that really you probably can't hope to achieve super high reliability. Like right out of the gate, you need to do a lot of personalized calibration. And I think it's I don't want to say it's like all or nothing, but it is a little bit all or nothing at times. Are you starting with the assumption that the rules are so clear that there's not going to be that much variability, and therefore it could be highly performant and highly reliable out of the box? Or is it going to take time and energy to build predictability, dependability, and trust? And so that ends up being oftentimes what product leaders don't want to hear. Even like what we're doing right now, every video platform in the universe right now has something like a background blur, right? And so what is a background blur calibrated on? It's calibrated on mostly a camera angle like what you're looking at me, where it's face forward, and well lit, pretty well lit. That's the training data. And so, as soon as we change to that camera angle, the world changes and the computer vision model can't do its job anymore.
It also can't do its job when it's looking at two people. So
unless it's right, exactly. Unless it's
designed for it,
it's designed for it.
Yeah.
So this is a distribution problem.
Yeah.
It's a distribution problem ultimately, because if you can control exactly the camera angle, then you can achieve high reliability. But how do you control variability in the camera angle? Do it for people, tell them how to do it, instruct them. That's a design challenge. So it's all this stuff. It's just, where's the variability and where can you put things in place that can reduce that variability? And at that point, then it can become like that really significant trade-off of, if you can't ever really reduce the variability beyond a certain point, then just go all in on relationship building and calibration and letting people guide the system, because you're going to be in a lot better position.
That's interesting that that there is a kind of messy middle there that you want to stay out of.
Yeah.
Yeah, I think it's totally lava.
Do you also think about the tolerance for unintended consequences? As an AI system will learn from experience post-launch. I still think of things in launches, but where the post design, it changes, and so therefore there's some level of unintended consequence. Do you think about the tolerance for those in each setting? Some things doesn't really matter, other things it really does.
Well, and who has to pick up the pieces?
Yeah,
like what you were saying at the start there, the starting at the point of who takes accountability for what and how.
Exactly. I mean, there's dramatically different perceptions for the tolerance. I mean, I'll start with the inverse, which is, what are people willing to give up sometimes in exchange for certain types of of privacy invasion or value tensions. If safety is the promise of a system, then people are far more likely to tolerate some form of privacy invasion. So weirdly true thing across domains. It's uncomfortable because of how manipulable it makes us all. But then by the inverse token, if you've said, hey, trust us, we're going to do all this stuff and your safety will be the thing that's preserved, and then you fall down on that, it's a dramatically bigger impact, right? Because somebody has exchanged value. So I think we think about it in terms of contracts, almost like that's more of a useful metaphor for me. Like what are the gives and the gets, or what is the perceived, the perceived value exchange. And so when the unintended happens, usually in my experience, it's because of a broken contract. Unintended usually is not considered. Unintended is a nice word for not considered. There's real unintended consequences. But we don't have to look at AI for unintended consequence. Like we have a lengthy history of, building cars that hurt women more than men because they were just designed by male engineers for male body type crash test dummies. So you could say women were hurt at a significantly higher rate in accidents, and that's an unintended consequence, but it's really more like an unconsidered consequence. Mm. And because the safety was the thing that we trusted, we gave those automobile makers money in exchange for our safety. That's a huge breach. We're
also asking in that particular case, if you extend that forward in terms of some of the other things we're worried about these days, it does place a great deal of a burden on diversity as a solution to unconsidered consequences.
Right.
And how do you? We're working across such long time spans for quite a lot of this that we do have to come back to this idea of what is the designer intending, and how do they set it up so that they're actively avoiding situations. They're thinking
That's
about,
right.
I'm making sure I don't do this, as opposed to, well, I'm just going to kind of run ahead and hopefully not too many unintended consequences pop up. We're
That's
asking
right.
a lot of these diverse teams to come up with these sort of, got it, cat caught it.
We're asking more runway too in the development of the products. So we recently we went general availability with this service called Custom Neural Voice, which is a synthetic voice generation AI technology. You can use a handful of voice clips, scripted lines that you can input, and then it can create what's called a voice font, which is a synthetic recreation or mimicry of an individual's acoustic and sort of some of their idiosyncratic vocalizations. It can include things like pauses and disfluencies and how they might smack their lips or whatever. But ultimately, it's remarkably realistic, and I don't think we talked about this publicly, but it's also not unsafe to say. Probably took us about 18 months to build from start to finish the responsible approach to doing it. When we first got engaged with that team, is it ever really the default thing for an innovation team to be like, let's look at all the ways this could go wrong? No, they're moving forward and charting new territory and improving on past benchmarks. But fundamentally what that technology is, and all generative synthetic technologies, are deception machines. You train a machine learning model to generatively produce synthetic content through qualitative measures of how believable they are. Said another way, when you can fake people out that a synthetic voice isn't a synthetic voice, or a synthetic 3D model of a human being is not a synthetic 3D model, you've successfully trained the model, right? So deception is the goal. And
What could go wrong?
What could go wrong? And we asked the teams, and they're like, "This is amazing, state of the art."
Passed the Turing test,
and they're not wrong. It is state of the art. It's amazing. Anyway, it required us, Dave, to your earlier question about unintended consequences. We had to invent an entire new framework to even figure out how to consider what could go wrong with this thing. We called it a harms modeling framework. Personally, it was like a kind of a crushing experience to have to build something like this, because my real desire is to start with the amazing, and like, how could we make the amazing happen? And, what could get in the way of the amazing thing happening? And, I imagine the three of us could talk a lot about, building buy-in from clients and customers and stakeholders by like demonstrating how much we love what their vision is, and then slowly breaking the news to them about how they might be off base, or how we can build something that could go into could help them get to that vision more effectively. But so in this case, we had to build this whole framework, and there's a whole category that we then had to like really invest energy into. There's the stuff that probably can serve as a good sort of foundation of like physically and emotionally hurting people. That's like a starting point. Then it goes into ways that it could deny consequential services, education, healthcare, jobs, etc. And it goes into infringements on human rights and ways that people's ability to gather, to have privacy, to right to fully and freely develop oneself, and then all the way out into erosion of democratic and societal structures. We had to invent that one for this case, because fundamentally what these types of technologies open up, and Facebook newsfeed is a perfect example of this, but it's not the only one, is the inability to trust our own cognition. So what's the damage? What are the unintended consequences when these systems get incredibly accurate at producing content that is believable or clickable or likable or consumable? Is we lose part of the inherent ability to trust ourselves, and stuff starts to fall apart. Evidence would no longer be fully admissible in a court of law if somebody could say, well, that was just deepfaked. The ability for individuals to convey the news could suddenly be put in doubt because, oh, is that really that news anchor? Did they really say that? I heard their voice on a fake advertisement the other day. And I don't know, it seems like you can make them say whatever you want. They're just a puppet. And so we built all of these systems. And like I said, it took us around 18 months to look at the intake process, the legal obligations, there's a gating framework. Every Wednesday I sell review customer applications for this technology. And it all boils down to social contract. Basically, there's a code of conduct of stuff that we all can collectively say shouldn't happen. And we detailed those out to be as robust as we could based on research that we conducted with Helen, to your point, with a broad diversity of people, from those who benefits were promised to, like people with speech impairments or degenerative diseases that might impede their ability to produce speech one day. They're like, oh, you guys are promising a big game. Like, have we talked to anyone who at least stands to have that benefit? And so we did. And we learned what they needed. And we baked that in. And we talked to people whose jobs could be affected, people that are voice actors or for a living produce something with their voice. And we baked that in. And we talked to lawyers, and we talked to people from the general public. And we especially over-recruited people that have certain privacy sensitivities or on the big 5 personality spectrum skew more introvert, because there's going to be impacts on those who speak more will be heard more. And those who want to be heard more through synthetic projection will be heard even more exponentially. Suffice to say, you do all the work, it's lengthy. And we couldn't have done it without incredible buy-in and belief that the unintended consequences were so significant that it was actually our responsibility to
there's two things that pop up in my mind about that. One is a question about if that's responsible and it took 18 months, how long would it have taken with quote unquote irresponsible? Just standing up a model and turning the technology on, training, getting a training set.
Exactly.
A month,
and would it have been possible to put the genie back in?
Yeah, but if it would have taken, maybe it took 2 months. What's a reasonable? What do you think?
You mean to go to market or to find out the unintended consequences and start to act on them?
No, just comparing that 18 months development time with an irresponsible, stripped.
Oh, yeah. Launch and iterate? Yeah. Launch and iterate. Yeah, for sure. They could have gone, easily. From the time that we began our engagement with them, absolutely. 2 months is easy.
So that sort of says that it's, the data point of 1, 9 times longer to do the responsible thing. That says, okay, so people will do it when, you've got a whole bunch of heritage here with both your history and Microsoft's history about being more ethical in this, more responsible. Plenty that don't. But there's this bit in the middle where how do you take an AI development in a kind of non-technology company where they're interested in doing a sort of something that might take 3 months, because that's about as long as people think a lot of the time. And then they get told, well, that's actually going to take a couple of years to do properly. Is that one of the places that you should say, well, if you're not prepared to do that, don't do it at all?
Yeah, I mean, we're hitting in the core of that tension, where I'll even see this with friends and colleagues who are doing something AI-ish in a consultative capacity, where they're going head to head with other agencies that are willing to effectively lie. The customer wants to be able to do X with 99.9% precision, and everyone knows it's not possible. And so, which side turns down the money? Right. So there's a certain game theory that between the marketing hype and between people trying to land customers. We're dealing with it right now in a big way. They can do it, why can't we phenomenon. It's a really significant, and it hits big companies too. It hits these big tech companies, and until they experience the negative outcomes for their business, oftentimes they're not really incentivized to think more deeply.
It makes me wonder whether in some places, whether the mindset is just incompatible in some ways, because you think about how an electricity utility thinks. The mindset is safety and security. It's a contingency focused mindset. People don't notice electricity until the lights go out, and reliability is kind of everything. And when you're in those companies, it is just drilled into you that that security of supply is the number one thing. And
that's right.
But that is completely the opposite mindset in say
it is
in some of these AI systems in large tech firms in particular.
We started to throw around this within our own team, and then with folks that we work with, because language is often the one of the biggest difference makers in changing kind of hearts and minds is finding shared language, getting more granular. We sort of say that traditional logic systems or traditional conventional logic systems produce something we call hard data. It's reliably debuggable data, like where we started with this conversation. But because machine learning systems are trained the way they are, put in the outcomes, develop the rules, incredibly influenced by the optimization characteristics and the training conditions, it produces soft data. It produces something closer to observations. I've tried predictions for a while. Sometimes I'll talk about it in terms of intuition. Sometimes we'll say it's opinionated. But it's all these attempts at putting not anthropomorphizing language onto it, but relatably squishy words.
Yeah, sort of like just level setting.
Yeah.
Where you can you get a more intuitive reaction to something other than highly likely.
And data.
Yeah.
Data from a language perspective. I have a rule for my team. Data is only to be used in cases where we can literally find no other word. Like it's a like I banned it from use.
Oh, wow.
And I'm like, you got to show me all the other things that we tried before we use the word data.
I can see his mind is just like
we're in the middle of a project right now. We might actually adopt that idea from you. Give you credit for it.
Yeah, because we're finding. I don't know if you got to that same point from a different journey, but the journey is that data has almost become a hopeless word to use. It is precise yet imprecise.
Yeah, the journey that just to get into this is that data can mean raw data coming out of an observational system in the world, like say a POS system in a store. Mm-hmm. But it can also be all the way up to a bar chart in a PowerPoint presentation given to the CEO of a company.
Data driven.
Exactly. That is, both of those are data to but so it's almost that data is what it means to the observer, right? Data is in the eye of the beholder. So for a data scientist, they're interested in raw data because that's what they're using for their job to make something out of. Whereas the CEO has absolutely no interest in seeing, whatever the quantity of data, raw transactional data is. The
wants
CEO
to know that went in there.
It wants to know the heritage of the data, right? Wants to know the chain of reality, if you will. But the CEO, she really wants to see a bar chart to say, this is how I'm going to make a decision. And but they're both data. But when you start using the word data, the person that you're talking to only hears what they think of as data.
It's so
100%.
Yeah, it conjures a different image for different people.
Yeah.
If I was that person, I should just learn to expect if someone's going to show me a bar chart, someone's going to show me a manipulation. Like the bar chart is formed by whoever sets whatever the reference points are for those data. You can convince me anything if you show it to me in that form. So you better have some good, solid granularity about what's being discussed. I mean, data visualizations are their intuition framings, or their opinion framings. They're great. It's fantastically useful. We need that stuff. We need symbols and metaphors that we can use to describe stuff. But data as a term, to me, is only valuable if we have a shared definition of the stuff that we wanted to pay attention to. Because it means that by definition, there's stuff you decided to not pay attention to. And if you can't talk about both sides, then you're not talking about data. It's like you're just talking about bias. Like you're just rendering some sort of which is cool. Again, we do that, but let's be real about it.
I love how you think of that, two sides, because only one side means you're putting bias in. It could be meaning, but it nevertheless is bias.
So I wanted to sort of a step back question.
Sure.
You've been dealing with these topics for quite a number of years. You're working at a company that perhaps has the longest corporate experience in researching AI, right? And has had some phenomenal successes, has also stubbed its toe, I mean, when you're talking about generative language, the word "te" is,
Sure.
chirping along in my memory. So you're working in an organization that stubbed its toe, so it has some experience of what failure feels like, and so will likely be more mindful of what, the impact of future failure, which is way more problematic today, right? So the generative language kinds of technology you're talking about today have way more potential downside impact than Tay did in its time. How do you think about advising AI designers, if you will, at other companies that don't have the same kind of corporate heritage and knowledge and understanding of the risk factors, where people will just want to get that personalization engine out and launched, or want to just have the answer that comes out of the enterprise, forecasting system, and they don't understand the downsides. And so suddenly you're showing up as the person that's just putting the brakes on success. Right. How do you help? What if you could give those people some advice, what would that be?
Yeah, part of my answer to that question is why I even made the leap to go help start this team. So I wanted to have a reference point that other people could refer back to. Also, Dave, I appreciate your generosity in and your optimism in the framing of that question. Sometimes people have their memories can be different of how those types of things went down. So it's good. It's good.
Humans.
I can invoke
a machine
Tay.
would remember the same thing.
It's definitely a thing that I and others can invoke. But the why, people didn't linger, and I will answer the question you framed, but people don't often linger in the why. This is the thorny part of it. Helen, you're like, it's probably 9 or 10x the amount of time it takes to go and invest in the proactive approach. And I can give you other examples of that, which probably that number works. But then also, do they invest the time into really understanding why something went wrong? Or really, I should say, why something behaved in a way that was misaligned with our values, right? So why did Tay behave the way it did? Because it was totally not done with consideration for feedback loops, moderation, filters. It was a learning exercise that was pitched as like real personality that was going to try to come online. It's a totally preventable thing, and many of the people that worked on that would tell you they tried to prevent it, but the prevailing motivation was launch and iterate. Just put it out there. How are we going to learn if we don't know? But so did they really stop and invest? I think different people have different takes on understanding why it behaved the way that it did. There's stories I could tell you off the record about that, at ways that Google dealt with some of the fallout from its different things. The lessons do get learned, but sometimes it's really hard to describe exactly in the language that is properly thorny. So back to your original question, all that stuff, like how thorny these questions are, how sensitive the conversations end up being, the perception that you want to avoid of being the person who pumps the brakes, or the pessimist, or even worse, the one who distrusts their colleagues. We should slow down and be responsible. What, you don't think I'm being responsible? So
it looks like you had that conversation.
Maybe. It all comes back to people stuff. The incentives do push people towards moving more quickly. They do push us to, default to trust with our colleagues. Say we hire the best and the brightest, and we should rely on them to do their jobs. And if you ask them too many questions, then you are risking undermining them or disempowering them. So the approach that we've developed is really more about triangulation of methods and tools and questions that get everybody off the hook of having to wear the tinfoil hat, pessimist hat, whatever.
Yeah, so it doesn't have to fall to one individual.
It's like, hey, for somebody who's not a colleague of mine at Microsoft, I would love for them to be able to say, hey, Microsoft has this team called Ethics and Society. Pretty much all they do is do co-creation with product teams where they come in and they try to help them get to yes. They try to help them get to ship readiness. We don't have a team like that, but they have their approach is really more about asking questions about how we realize the awesome stuff we're trying to make. They have this harms model where it's just a bunch of prompts. We can all get together and maybe just answer some of these questions. And by just, let's go through this process and answer some of these questions and look at some of these theoretical examples. Do we know how to answer these questions? Do we know we're going to avoid some of these potential outcomes? Let's do that together.
And if it delays shipment by 6 months, we can just blame Josh.
Come knock on my door, please. I do joke about that sometimes. They'll be in the Q&A session, after a talk or something. And there's that person who's in a group where design is kind of a third class citizen or something. And they're like, how do you convince people? And I'm like, well, it's easy for me because I'm not working with you right now. And I can just say, why do you have design if you're not going to give a damn about usability? Why do you have design if you're not going to give a damn about research? Because research is the only thing that makes design possible. And they're like, can you come say that to my leader? To my senior, and I'm like, sure. How do you channel those conversations so there can be back to the AI incentive? They're doing it. Why not us? If we can get more of those examples of there's this framework that we can all do together, a set of questions. It's not me, it's them. Then I hope that there can start to be a bit more social opportunity where people don't feel like they have to put themselves at risk by raising some of these questions, but rather they can just say, have we just done the exercise together to all know that we have a similar idea about what it would look like if this thing behaved in a not great fashion? Questions are the starting point.
Yeah. I got a totally different question that sort of came to me when I asked the very first question around human-centered. One of the things that intrigues me is, how do we balance human-centered when humans actually aren't necessarily good at knowing what they want or what's good for them?
Right.
And how have you come to think about that as, that in some ways the societal discussion has really shifted in the last few years from around this sort of whole concept of, well, what's fact, what's truth, what's useful and good to know and do, but might not feel good to know and do, but is good for you as a person. How have you come to think about the evolution of human-centered as a term?
Mm-hmm. Yeah, it's another word that might get... I feel like design thinking is at risk of being killed by tech right now for this reason.
Google has now said that it's design feeling.
Oh, good.
Yeah. I saw something on that this morning.
Also, my favorite thing to do, I'm careful about this, but when somebody trots out the Henry Ford quote, I'm like, yeah, he never said that. If I just asked people, they would have told me they wanted a faster horse. You should look that up because he literally never said that. And for that reason, you should probably start with research. So let's talk about user research.
It's a good segue.
I'm careful because it's easy to sound like a jerk. But it's like hilarious how misused that's been for ironically accomplishing its own goal. You know, you're like, I can invent a quote about how I know best. I don't even need to know if it's a real thing. I just want people to know that I know best. Right? That's effectively the statement. So human-centered doesn't mean just doesn't just mean ready to, made to order. There is a problem, I think, in the community that we're trudging through right now, where, I don't know, maybe about 10 years ago, like for the majority of these like tech companies, they woke up and realized, oh, design is really important. They didn't necessarily invest in like what it means to do design, but again, we sort of got like a semi seat at the table, maybe a seat at the kids' table, and as a result, there's been an incredible over-indexing on design for usability and research, evaluative research, right? Just research that confirms whether or not something did what we thought it would do. Could they click on that thing and get to the next screen? Great. Success.
Done.
We did the research. And so what we've missed in that like kind of huge expansion of design is even the need of people saying like, oh, it's capital D or lowercase d design. And I'm like, nope, don't do that. It's just, did you take the steps to understand the people that are involved, understand their lives, their motives, their needs, come up with potential ways that you could satisfy those needs, develop measures that are proxies that would help you understand whether you're satisfying their needs, and then go build the thing and continue to make it better. Like it's a very different approach that requires, again, a bit more time, a bit more thought, and a lot more empowerment into doing things like generative research and rapid prototyping and testing. So, all the more important for machine learning because the AI development lifecycle is actually a lot closer to the hardware development lifecycle than it is the software development lifecycle. It's, I think, not a well understood conversation topic, even in big companies that I worked at. It's like to really get into a spot where you can ship a robust machine learning model and all of the trappings around it, because it's never just one model. Like when we built Google Clips, it was 24 different models that we trained to do one thing, which is snap a decent photo of somebody, You're talking about that more 2 to 3 year process. Maybe if you're fast tracking it, you're talking about 6 to 12 months. So I hope that this is like a little bit of the push to get us back into real human-centered design, the real understand, define, diverge, decide, prototype, validate, ethnographic all the way through like that. Like, I hope it'll get us back, because if we think about how absurd it would be to build a hardware product without actually doing any kind of anthropometry up front, like really measuring who the people are and how they'll use it and what are the tolerances physically and what are the size differences between them, how absurd it would be to just be like, let's just come up with a spec and build it, and then we'll see if it fits people after the fact. Like, that would be absurd. It'd be absurd to build a building and not understand where you're going to build it. You're just like, we sketch it out. It's an amazing building. It has all of the best everythings. And then, it doesn't fit on the city block that we put it in because, the grade is too, like, whatever, right? Like, these are the absurdities that come into more mature domains. Industrial design is woven side by side with engineering, mechanical engineering, industrial design, aesthetics, materials, same with architecture. So digital design will get there. We have to find ways to weave it together to become a bit more transdisciplinary. Designers need to understand more about.
Yeah, and fascinating thought to think that there's a better parallel is
hardware design.
Hardware.
Yeah, and I
not
find,
intuitive, but really interesting.
And I'm getting a bit of my my bias to history is when you talk about design really becoming a big thing, say maybe 10 years ago. There is
in terms of staffing levels.
Yeah, there is a correlation to that being the time when everybody decided that maybe they wanted to be a bit more like Apple. Because suddenly Apple went from the 5% market share, company that everybody could look at and say, oh, well, yes, they're just about, they're just a design company, to, oh, whoops, the iPhone. Maybe we all want to be a design company too, but missing the mindset of actually how things are designed there, right? Taking it and trying to rapid fire it and saying, oh, well, we could do the same thing, but on the schedule we want. And this interweaving of that plus sprinting and agile and everything else, saying, oh, we can design and, all of these short-term things. I feel like this is we could come back to this and have a very long next podcast purely on that one topic about how to truly bring design to its in its true form of making something work, right? That it's not just about which pixels and which color tone you're using. It is about how does something work, and taking that into the context of what AI is and what does it mean to actually make AI work.
That's right.
So anyway, we've very much enjoyed all of this time with you, and I want to thank you very much.
We've got one closing question, remember?
Go ahead.
Different than we've asked anyone else, because you're actually an AI designer. But what two things would you find the most valuable if the worlds of neuroscience and behavioral science and psychology could find them out for you?
Wow. Those three fields are really fascinating too. When you floated those three as prompts, the first thing that came to my mind was about how they could teach others from some of the hard lessons that they've learned. I don't think this is my answer, but it's my filibuster while I come up with my answer. Behavioral science is probably the most recent one. When I think about like the reproducibility crises, ongoing reproducibility crisis in behavioral science, and lessons learned, reformations made, neuroscience has really needed to make this move towards variability being considered the norm rather than there being perfect truisms in the structures of the brain. We say like everything is sort of like standard deviations away from now, rather than saying this is the part of the brain that does happy. This is the part of the brain that does food. Now they understand, like, it's really, there's sort of population overlaps and similarities, but then it's just standard deviations away from the mean. And so the hard-fought, hard-earned lessons of that. And then in psychology, as probably the oldest one, just thinking back to like the ethics of how you experiment on people and the hard lessons learned of experimenting without consent or experimenting with unknown ramifications, near-term, long-term. Obviously Stanford prison experiment is like the most notable one, but there's no shortage of psychological experiments where it's just sort of like, yeah, for the greater good, we're going to do this because we can get to a spot where we can understand people better because science. So all three of those, I just thought about like, what is it about the hard lessons learned? And if I could bring it back, I think many of us struggle right now, and I think the three of us struggle with it a lot. Gosh, I wish I could better impart onto others foresight. It's like the hardest part of my job for the last 6 or 7 years has been that, like, that kind of tension from that, would you rather have, some wonderful answer, but then not be able to share it with anybody, like that whole like dilemma. It's felt like it's been clear as day to me for probably 6 years now that machine learning needs to be built as a bunch of models which are really more like small, focused, hyper-specialized experts in very focused domains that operate in multitudes. And rather than being these singular monolithic systems that do one thing, it's like clear as day to me. I'm like, we need to be looking at this in how do I make many and lots of specialization and dynamics and diversities. And so I've been kind of on a struggle of imparting that kind of foresight onto others. And I would say, lukewarm success. It's still a work in progress because it's too hard. It's too hard to sort of take all the lessons hard learned and like give them over to somebody else. Human beings just have to experience stuff for themselves. Mm-hmm. Mm-hmm. We know as parents, we'd love to tell our kids, don't do that. You should do that. Don't do that. More of that. And they're like, that's cool. I'm going to go over here and experience it myself. Mm-hmm. It's just a human condition that people have to experience stuff for themselves. So I guess that's for those disciplines or those scientific disciplines, I'd love to understand more about how we can more effectively impart foresight on one another in ways that don't just limit our capability or our capacity, but actually help reach us. I have no idea how I'd approach that study, but God, I want an answer.
All right. Well, that's a terrific answer.
Oh, thank you. Really appreciate the time. This has been fantastic. We've really enjoyed it.
Thank you both.
Solid state.